The problem that we will be solving today is subarray sum equals k. Here in this question, we'll be given an integer array nums and integer k. Okay, we need to return the total number of subarrays whose sum equals to k. A subarray is a contiguous non-empty sequence of elements within the array. So what does this question mean? In the sense, we need to return the count of the number of subarrays that we can continuous subarrays with continuous elements that add up to k. Okay, let's look at the first example. This is the array that we are given with, and our target is to get 2 out of the sum of any two elements that we take in our subarray. So out of this array, we can form two subarrays, right? First, by taking the first two elements, because they are continuous. The first two elements, that is 1 and 1, we get 2. And next subarray is by taking next two elements. Again, the total is 2. Moving on to the second example, we have 3 elements in the array, that is 1, 2, 3. So our target is to get 3 as our total. And when we take first two elements in from the array as a sub-array, we get the sum as 3. That can be counted as 1. And the last element itself is 3. So we can take that as a separate sub-array, and that can be counted as one of the array. So totally we have 2 sub-arrays counting up to 3. Now let's visualize this more nicely so that we could code it properly. Here, let's consider this as the example that we saw earlier, and the k, our target is to make up the sum of 2. First of all, we initially have to map the first element, that is 0 to 1. In the hash map, in the position, that is in key, we'll be storing the prefix sum, and in the value, we'll be storing how many times the prefix has appeared. So then we need to traverse through the given array. Here, the first number that we have in our array list is 1. So 1, we take the first one, and then the prefix sum will be 1, because initially the sum will be 0. 0 plus 1 is 1. And what we need to get our target, that we get when we subtract the sum from the k. So here it will be 1 minus 2. 2 is our target, right? 2 is k. So we get minus 1. And then we check if 2 is present in our map. No, because we are just getting started with the hash map, right? How can we have any element? So it's a no. And the count will be 0 because we still didn't form any subarray which forms the sum as 2. So we move to the next element, that is 1 again. So the prefix sum will become 2 because 1 plus 1, 1 plus 1 is 2, right? Then we need to check if 2 minus 2 is 0, and found how many times is that found? Once, because we initialized 0 once over here. And then the count becomes 1. And moving on to the next number, again it's 1. We add that to the prefix sum. What the total sum is 3. 3 minus 2 is 1. So how many times does 1 appear? Once, right? The key 1 is present in the map once, so the count becomes 2. So valid subarrays are 1, 1, that is from index 1, 0 and 1. It's one of the set. And second subarray is 1, 1 again, that is 1, index 1 and index 2. So totally our answer becomes 2. So the main idea that we need to look into over here is that current prefix sum minus the earlier prefix is equal to k. This is the main idea. Therefore, the earlier prefix is equal to current prefix minus k. We could look at this formula. See, let's consider our current prefix sum as 3. So current prefix sum minus k. What is it? 2. 3 minus 2 is 1, so 1. This is the earlier prefix that is here. We have it once. That's how we usually identify it. This is also once because we initialize 0 to be 1, right? So it's already present in our map. That's how it works. Now let's move on to the algorithm. We need to store 0 mapping to 1 in the hash map at the beginning, and when we need to calculate the running prefix sum, find the needed, that is prefix sum minus k, add its frequency to count. That is where we track the possibility of getting the total count to add up to k. And then we need to store and update the current prefix sum. Finally, we need to return the count. Now let's start coding on LeetCode. First of all, we shall have to create an empty hash map with integer types. The first integer is for the prefix sum. That has to be remembered. And the prefix sum maps to how many times the prefix sum appears in the hash map. The frequency of the prefix sum, basically. New hash map. And then map dot put 0 to 1. This line is basically to help us calculate the subarray forming from index 0. Then we need to initialize a variable called prefix sum, initialize to 0, and then we'll also need count, which has to be written through to this problem, and then we need to traverse through the array. Calculate the prefix sum. Prefix sum plus is equal to nums of it's n, right? Yes. And then we need to calculate the needed. How much is needed for this prefix sum to form our target, that is k. Sum. Okay. We have to then find if needed is present in our map or not. If it's present, then count plus is equal to map dot get needed. And then we need to increase the frequency of our prefix sum. Prefix sum comma map dot get or default prefix sum comma 0 plus 1. That is it. Then we need to return our answer, that is count. Store the current prefix sum. That is what we did over here. Okay, now let's talk about the complexity. So how many times did we traverse through the array? We traversed only once, right? So the time complexity becomes big O of n. And then talking about the space complexity, we use HashMap, which can store the prefix sum of n elements, that is the number of elements in the given array. So the space complexity also becomes big O of n.